All right, we're going to do a electrochemical cell, also known as voltaic or galvanic cell, from beginning to end. There were several votes for iron, so iron is going to be one of them. You're going to have an electrode of solid iron, and it's going to be in a solution of iron ion. So let's just use +3 for lack of a better term. There's a salt bridge between the two cells. The other side is going to have, Angelina chose titanium. You could use copper, silver, or gold, but if you do, know that it's always at the bottom of table J. Okay, so copper, silver, gold, always at the bottom. I'm not going to choose those ones, even though they're very common in cells, because we just want to have to look it up. So this is going to be titanium, a piece of metal titanium, in a titanium solution, +3. Let's just keep them both +3 for ease of calculation. Titanium +3. And so what you do is you look on table J. Titanium is above iron. They're both about a middle of the board, but titanium is higher. So titanium is going to be the oxidizing one, or the one that's oxidizing. It's going to be the anode, and it's going to be losing electrons. Always write those three things on the side of your cell. The other side, therefore, must be your reduction. The other side must be the cathode, red cat. And then the red cat says GER. This is where the electrons are gaining. This is losing electrons, and this is gaining electrons. The electrons must be flowing through in this direction. Okay? Or they flow down table J from titanium down to iron. And so there you go. You know that since the electron is going this way, it has to go in a circle. This is the direction of the ion flow. Whatever's in the solution with iron is flowing in that direction through the salt bridge. So in other words, if iron is reducing, that's +3, has 0, therefore it must be going from +3 to 0, Fe solid, 0, plus gaining electrons, oh whoops, 3 electron goes over here as a reactant, also 3 negatives plus 3 positives equals 0. So there's nothing there. This is our reduction half reaction. Oxidation is going to be going up between 0 and +3. It's got to be titanium 0, solid, goes to titanium +3. Now, I know the high side can get the electrons, +3 and 0, so I've got to put 3 electrons over here. And oh, by the way, since we're losing electrons, they've got to be coming out as a product. Also, by the way, these electrons are coming out through the wire, so that makes sense. So this titanium solid, an atom here drops off into solution, and when it does, it kicks the electrons up in this direction. Electrons flow over here, the iron in solution grabs them, ends up combining together to make a bit of iron on the thing. This electrode's going to get larger, this electrode's going to get smaller. You can combine these together, therefore, 3 electrons front, 3 electrons back, say Fe +3 plus Ti solid goes to Fe solid plus Ti +3. Combine everything on the right half of the arrow, everything on the left half of the arrow. By the way, iron is with a date. Is titanium popular enough to steal it? Yes, it is, because it's higher on table J. Iron leaves by themselves, titanium goes home with a date, and you've been replaced.